Okay, so members, welcome to this lesson. Today we are going to see how do we apply the integration by parts technique. Integration by parts, we use it when we have a product of two functions, when we are integrating those functions. So that's when we use integration by parts. Or there's another way, if you don't use you can use integration by parts using the basic technique. I did that in the last lesson, so we are going to see how do we now use this one when we are using the formula. Now from here, the formula for integration by parts is always, if you have the u, the v is always equal to uv, so you always need the u, always need the v. How are we going to get the v? We are going to just integrate the v, then we need the v, then the u. How are we getting the u? By differentiating that u function. The question is, how do we choose the u? How do we choose the v? Always, we are going to use the Riyat acronym. Riyat stands for, this first is log, this one is inverse function, algebraic function, this one is street function, and this one is exponential functions. Now, a function that comes first in the Riyat is always what we let it to be a u. So u is always a function that in that product comes first. So let us see this example now. If I have x power ex, this is algebraic and this is exponential. So you come here and check which one comes first. So you see that we have algebraic and exponential. So this one comes first, so this one becomes your u. Let us handle this example. We are going to see as we move on. So see that when I have x and the ex, so I have x is algebraic, then ex is an exponential. So see that a comes first before e. So this a now becomes our u. So if you compare here, so my u is going to be x. So my u is going to be x. And then the remaining, if I have the u, now the remaining thing is going to be the v. So that the remaining thing, the whole of this is going to be my dv equaling to ex dx. Now, in this formula, I need the u, which I have already. I need the v, I'm going to integrate this to get v. I need the u, I will differentiate this. So if I differentiate u, I'll get the u. When I differentiate x, I get the x. Then here, when we integrate this, so these ones we are going to integrate, we are going to integrate dv equaling to ex dx. We are also going to integrate. So that here, when we integrate that, so that here, uv is going to be, when we integrate ex, we get ex. Now, we come and we substitute into this formula, which says that now my integral of u dv will be uv minus the integral du. My u is here x, my v is here as ex, then minus the integral. My v, from here my v is ex, my u, so from here the u is equal to x. Now we come and complete this. So now my integral will be x minus. When we integrate this, we get ax. So ax now plus a constant of integration. And that's how we tackle that first part. When I come to 2, where we have our integral as natural dx. So we come and state our Riyat acronym, this one. So see if I state it here, side. You see what comes first? You see that there is a silent 1. So this here is just a 1 there. So meaning that what comes first is that we have no here and we have an algebraic here. So meaning that this one log comes first, meaning that now log is going to be my natural log is also log like this. So from here my u is going to be natural log of x. Then the remaining thing, 1 of the x, is going to be my dv. So I need the u. So from here my du, when I differentiate this, I get 1 over x dx. Here to get this, you integrate this side. So if I integrate dv, integrate dx, that my v is going to be x. Now we substitute in our formula. our integral will now be, our formula is here, u, my u is this, then v, so I have x, natural log of x, then minus integral of v, which is x, times du. From here, my du is this. My du is dx over x. And so that this one will vanish. So now my integral of natural of x, dx will be x, natural of x, then minus. So that here we shall be having only integral dx. So if you complete that, so this will be x, natural of x, then minus, and integrate this will get x, then plus a constant of integration. That's how we can easily use it. When I come now to 3, I have my integral equaling to x cos 2x dx. From here, this that we have, when I use my liat, you see I have the algebraic function, and I also have the trig function. So that algebraic comes first, so this one becomes my u. So now my u is going to be the algebraic function is x, then the remaining thing is going to be all of this is going to be the v cos 2x dx. So we get our du. And this I get 1 dx, comma. From here, this is when I integrate this. Okay, my dv will be equal to cos 2x dx. Then I integrate them so that I can get my dv. I mean here, so my dv from here is going to be, when we integrate this, we first differentiate the angle, we get 2. Its reciprocal, which is a half. When we integrate cos, we get sine of that same angle. So now substituting into our formula. So now my integral will be, the same, it's always uv, my u is here, x, then this one is half, the v, sine 2x, then minus integral, my v, which is half, how we call this half out, then sine 2x, then du, my du is dx. So if you simplify this, it's that my integral is going to be x over 2 sine 2x, then minus half into, when we integrate sine, we get a negative first of all, then the reciprocal of the derivative of this angle is a half, then cos 2x, then plus c. So writing the order of that now, my integral of x cos 2x dx is going to be x over 2 sine 2x, then minus this minus and minus is going to give us a positive quarter, then this cos 2x, then plus constant of integration. When I come now to the fourth, line number 4 is having integral of x tan inverse of x dx. From here, so that if I use my liat, you see I have algebraic, but I also have an inverse. Those are the two things I have. But you see that the inverse comes first. So this inverse comes first, so it becomes my u. So what comes first in the is always a u. A logarithm, inverse, algebraic trig, and exponential, simple as that. So now my remainder, the all of this now, I mean the remainder which is, so my dv. So this is here, so this x dx becomes my dv. So in the differentiate to get du, when we differentiate tan inverse of x, we saw that we get 1 over 1 plus x squared and I'm differentiating x. We'll integrate this so that my integral of dv equaling to the integral of x. So that from here, my v, we'll integrate this, we get x squared over 2. So that's what we have. Then we substitute our formula. Our formula is u dv is equal to uv minus integral. So my u from here is here, x tan inverse of x. The x is going to be my u from here, then my v is here. So let me start with the v because it's the product, so I can start with n. Then tan inverse of x, then minus integral of now v, my v is x squared of x squared over 2. Then du, from here my du is 1 over 1 plus x squared dx. So now, to write that base integral is going to be x squared over 2. Then this half out. Then now we see that this integral is improper. We first go and we use long division so that this one is improper. So if I'm to use long division here, I'll say I have the divisor as, then I'm dividing x squared. So this goes here, 1 times this, then 1 times this, then the subtract. So we have a negative 1, meaning that the whole of x squared of x squared plus 1 will be the same as 1 b1, then plus negative 1 over the divisor x squared plus 1. So we write it that, now we have my integral as x squared, then minus a half into now the integral. The whole of this is this 1 plus negative 1 over 1 plus x squared dx. So this will be now integral x squared over 2. Then minus, we can easily separate this and be having this times this to get a half integral of 1 dx. This negative and this negative get positive a half integral dx over 1 plus x squared. Now my final answer, so the integral of x is going to be now this, then minus, when you calculate this, we get x over 2, then plus a half, when you calculate this, we get an inverse of x plus c, and that's what we get. So remember, that's how we apply for integration by parts. This real acronym is very important. Don't forget to subscribe to the channel. I wish you the best.